So in this video, I'll show a simple example of applying disk method. So here we have the general formula for simple disk method, and what we're going to rotate is the unit semicircle. That is to say, a semicircle that has a center at the origin and a radius of 1, and it's all above the x-axis. So we know the unit circle has an equation of x squared plus y squared equals 1. If we solve for y, we get y equals 1 minus x squared, square root of that. Now, of course, we would take the positive square root for above the x-axis, and it would be this times a negative sign for the semicircle below the x-axis. So this is the actual equation of this particular function, y equals square root of 1 minus x squared. And this is going to be our r of x. This is going to be the radius that is rotated. And so the volume is going to be pi times the integral from -1 to 1 of this r of x squared. So this is the integral from -1 to 1 of 1 minus x squared dx. And of course the antiderivative of 1 is x. The antiderivative of x squared is x cubed over 3, evaluated at 1 and -1. And so we get pi times, plugging in at 1, we get 1 minus 1/3, minus, plugging in at -1, we get -1 plus 1/3. And so what this is, after a little bit of simplifying, we see that this is 2/3 plus 2/3. And so what we get is 4/3 pi. And in fact, if we think about it, this is exactly what we expect, because if you rotate the unit semicircle, what you're going to wind up with, and this is not a very good drawing, but what you're going to wind up with is the unit sphere. You're going to wind up with a sphere with a radius of 1. And of course, from Archimedes' amazing formula, if we have a sphere of radius of 1, that must have a volume of 4/3 pi. So this is an example of a disk method calculation where we can verify using Archimedes' geometry formula.